We are continuing with trigonometry in lesson 3.2. Here we discuss the other trigonometric functions. So last time we had angles, we had the unit circle, and we had cosine and sine. But there are four other trigonometric functions which we will discuss right now. First, let's recall, if you have an angle theta in standard position, which means its vertex is at the origin, its initial side points along the positive x-axis, and then its terminal side intersects, well, it intersects the unit circle at some point, xy. So here would be the point, xy. For this theta I have drawn, you notice it's in quadrant 2, which is perfectly fine. But here's my angle theta. Well, the cosine was the x value, and the sine, that is the y value. We can immediately define these other four trigonometric functions. The tangent is y over x, but we could also write this as sine over cosine. Secant of theta is 1 over x. But we could also write this as 1 over cosine. Cosecant theta, this is 1 over y. We could write this as 1 over sine. And finally, we have cotangent theta. This is x over y. And similarly, we could write this one in terms of sine and cosine. You notice this is cosine divided by sine. So this is it. This is what we're discussing this lesson. But what we want to do is practice evaluating these four other trigonometric functions. First, let's discuss the values, certainly not for all theta between 0 and pi over 2, but for the special ones that we remember, namely 0, pi over 6, pi over 4, pi over 3, and pi over 2. I have the values of cosine and sine. These we discussed last time. And then I can just use the definitions of these other four trig functions to write down the values. Okay, secant, we'll do secant first. Okay, I just go all the way across. Secant was 1 over cosine. And so I just take 1 over everything in this first row. 1 over 1 is 1. Now, if you take 1 over square root 3 over 2, square root 3 over 2 is in the denominator, and we will invert and multiply. So this will be 2 divided by square root 3. If we wanted to, say, not have a square root in the denominator, we could multiply by square root 3 divided by square root 3, and we could write this as 2 times the square root of 3 divided by 3. Either one of these is the correct answer. Two different ways to think about the secant of pi over 6. Now, pi over 4, we would have, again, it's 1 over square root 2 over 2. This would be 2 divided by square root 2. But here, if you multiply square root 2 in the denominator, square root 2 in the numerator, we just get the square root of 2. Pi over 3, we take 1 over 1/2, we get positive 2. And here, look, undefined. We cannot divide by 0 in mathematics. Now, cosecant is very similar, except we take the second line and we take 1 over. Cosecant is 1 over sine. So it's here that's going to be undefined. And then we have 2. We will have the square root of 2, which is 1 over square root 2 over 2. And then here we will have 2 square root 3 over 3. Okay, these calculations we in fact thought about in the line above. Finally, 1 over 1 is 1. So that fills in our line for cosecant. For the tangent, you see we take this line, sine, and divide by this one. The tangent is sine over cosine. And so for each entry, we take sine divided by cosine to get the value of the tangent. Well, 0 over 1 is 0. And then if you have 1/2 divided by square root 3 over 2, this will be 1 divided by the square root of 3. If you want to, kind of like we did, say here, if you want to not have a square root in the denominator, multiply by square root 3 divided by square root 3, and we get the square root of 3 divided by 3. What about pi over 4? Well, you see what happens when you take this divided by this? It's the same value. And so we just get 1. The tangent of pi over 4 is 1. Tangent of pi over 3. We take sine pi over 3 divided by cosine pi over 3. This will be square root 3 over 2 divided by 1/2. When you invert and multiply the 1/2, we just get the square root of 3. Square root of 3. And here, sine over cosine, 1 over 0, this is undefined. So you see, the tangent of pi over 2 is undefined. Finally, cotangent, we take cosine and divide by sine. So 1 over 0, this is undefined. Here, I would have square root 3 over 2 divided by 1/2. This we did that kind of calculation for the tangent. We just get square root 3. But you notice here, I still have square root 2 over 2 divided by square root 2 over 2. This is 1. So the cotangent and the tangent of pi over 4, they're both 1. Then here you notice we have 1 over square root 3, which just as we did for, say, the tangent of pi over 6, you could write this as the square root 3 over 3. Finally, for the cotangent pi over 2, we have 0 divided by 1, which is 0. So this gives you many values of secant, cosecant, tangent, and cotangent, and it just uses the sine and cosine, which we talked about in the last lesson. But the important thing to stress here is we do not need to memorize these. I mentioned you should know these on the unit circle, and you should know how to use reference angles. But I personally do not memorize all of these because that's a lot to keep in your mind. The good news is that anytime you need a secant, a cosecant, a tangent, or a cotangent, we can evaluate using, well, sine and cosine, and then of course, reference angles. So let's practice some of this right now. You'll notice I've drawn a unit circle for each one, and I went ahead and wrote the initial side of the angle. And I am not going to refer back to my chart about the values of secant, cosecant, tangent, and cotangent. I'm going to evaluate all of these really using sines and cosines and reference angles. So the first one is 3 pi. We go around 2 pi, and we go around 1 more pi. So 3 pi is out here. This is my angle. Well, you notice here the cosine is -1. And so secant of 3 pi would be 1 over the cosine of 3 pi. This is 1 over -1, which is -1. So here's my first answer. Now let's move on. The next angle is minus pi over 6. So we need to move clockwise by pi over 6, which would be something kind of like this. You notice we are in quadrant 4 here, but this is just 1 over the sine of minus pi over 6. We are in quadrant 4. As I mentioned, the sign is negative. So this is going to be 1 over, well, reference angle pi over 6. The sine of pi over 6 is 1/2. So this is 1 over -1/2. So the cosecant here is -2. The next angle is 5 pi over 4. Well, we move by pi, that gets me to here. And then there's 1 more pi over 4. So we are here. So we are here. This is in quadrant 3. Cotangent would be cosine 5 pi over 4 divided by the sine 5 pi over 4. Well, in this quadrant, cosine and sine, they're both negative. In fact, I could answer this right now just realizing that this sits along the line y equals x, so the cosine and sine are the same, and so the cotangent will be 1. But if you wanted to write out the details, this would be negative square root 2 over 2, and then divided by the same thing, negative square root 2 over 2. My reference angle is pi over 4, and so we get 1. The cotangent of 5 pi over 4 is 1. We have another secant, but let's think about the angle first. 5 pi over 3. So all the way around is 6 pi over 3. Then you back up. Pi over 3 would be about here, would be 5 pi over 3. 5 pi over 3 is approximately here. We are in quadrant 4. Cosine is positive here. Cosine is positive, and the secant is 1 over the cosine. This will be 1 over cosine of 5 pi over 3. Reference angle pi over 3 has cosine 1/2. And in this quadrant, cosine is positive. So we have 1 over 1/2, which is 2. So the secant, 5 pi over 3 is 2. Now, before we move to the next page, maybe I'll just write the reference angles for the ones that had them. Here, we didn't really have a reference angle because the 3 pi fell along the x-axis. But here, the reference angle was pi over 6. Here, the reference angle was pi over 4. And the one we just worked, the reference angle, was pi over 3. Wonderful. Next angle, 7 pi over 6. Well, here is 6 pi over 6, which is pi. Now we go one more, pi over 6. So it's going to look something like this. Okay. I will start, as we were doing in the last view, I will add my reference angle. It's pi over 6. Okay. Tangent is sine over cosine. Sine 7 pi over 6 divided by cosine 7 pi over 6. In this quadrant, you see both the sine and the cosine are negative. So in my numerator, while the sine of pi over 6 is 1/2, but it's negative in this quadrant. So we have negative 1/2. And then in the denominator, I have negative square root 3 over 2. When we say invert and multiply, I get positive 1 over the square root of 3. Or, as we were doing on the last page, if you say multiply by square root 3 divided by square root 3, I get square root 3 divided by 3. So I will underline this one. But really, 1 over square root 3 is correct also. Now the next two I find quite interesting, although the phenomena shouldn't surprise us based on 2 pages ago. But let's think about them. Let's draw the angle. I have tangent of minus 3 pi over 2, which means I'm moving this way, okay, clockwise. So here would be pi, and then I go pi over 2 more. So my angle, terminal side, is here, okay? Well, what happens when I try to do, say, sine minus 3 pi over 2 divided by cosine minus 3 pi over 2? Here's where we realize we have some problems, because this part in the denominator right here, this is 0. We cannot divide by 0, so we would get 1 over 0, which is undefined. So that's the answer here. This is undefined. The tangent of negative 3 pi over 2 is undefined. Now one more, cosecant minus 5 pi. First, let's draw our angle. Once again, we are moving clockwise, we have minus 2 pi. We have minus 4 pi. And then we go one more pi. So minus 5 pi is out here. But now something similar to the last example is going to happen. This will be 1 over the sine. Cosecant is 1 over sine of minus 5 pi. And here's the issue. I'll highlight it again. The sine of minus 5 pi is 0. So the cosecant of minus 5 pi is undefined. And I ended with these two, even though we saw some undefined showing in our box. Here, right, we have undefined, 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 undefined. All 4 of these functions, the new ones that we talked about in this lesson, are undefined sometimes. But I still wanted to include an example where we saw it again. And this is my important comment that we will end on, that tangent, cotangent, secant, and cosecant, well, they do not have domain, all real numbers. So at this point, you can move on to the exercises for lesson 3.2. Practice evaluating these 4 new trig functions and using some reference angles. Thank you so much.